uses of electrolysis next. What are the uses of electrolysis? Industrially, electrolysis is used for the extraction of metals from their ores, or that is in their raw forms. So we can extract metals from their raw forms. We can also use electrolysis in plating. It is applied in electroplating, and then also more in the purification of copper. So that is to say, if we want to get pure copper, the impure form will be made the anode, and the one we are to get will be the cathode side, just like we saw. And then we're going to be using the solution of copper, of course, so we can get the real copper out of the impure form. So it is just like electroplating, also similar. And lastly, we can use electrolysis in the production of chlorine, hydrogen, and sodium hydroxide. So when we carry out electrolysis of brine, so in the electrolysis of brine, we are going to get chlorine, and hydrogen will be also produced, and of course we'll have sodium hydroxide. That is actually the products that are obtained when we carry out the electrolysis of brine. So these are the uses of electrolysis. So away from that, talking about electroplating still, since we have seen the uses of electrolysis, let us get to understand how electroplating is done. So this is a diagrammatic expression of electroplating, for example. So if we are to electroplate any spoon, let's say a spoon that has to be electroplated to silver, so we can see that the spoon will be made as a cathode and the silver will be made as the anode, such that the electrons leave the anode and go to the cathode, and of course we have the silver nitrate as the electrolyte. So the silver ions from the anode will go into the solution and of course will be deposited on the cathode spoon. So the spoon, which was a former metal, a non-desirable metal, will now become silver coated. So this is how electroplating is done, and we can see that more appropriately here. As you can see, we can see that with this demonstration. Let's look at this demonstration. So we can see from this demonstration that we want to electroplate brass. So the brass is the cathode and the anode is copper, so we want to electroplate it. So you can see the copper going to the brass and has been pasted on the brass as electrons comes in. So that is reduction, but at the anode side we can see oxidation taking place, while reduction takes place at the cathode side. So this is actually what we have explained before, just for us to understand better. So you can see that the cathode will now get to increase in mass and of course in size. So but the anode will be diminishing gradually. That is the mechanism of electroplating. So you can see that the anode will diminish, will keep on wearing away. The anode will keep on reducing in mass and size, but the cathode will keep increasing. So this is the mechanism of electroplating. So we are done now with the uses of electrolysis. So let's proceed to our next subtopic, that is oxidation and reduction reaction. When we talk about oxidation and reduction reaction, we have to define some terms, and let's look at them very well. So first, in oxidation, it can be defined in the following ways: in terms of electron loss, in terms of oxidation state or oxidation number, in terms of hydrogen, and of course oxygen. So in terms of electron loss, oxidation is defined as loss of electron. Loss of electron. So for short, we can simply say oxidation is loss. It is abbreviated as, redox reaction generally is abbreviated as oil rig. Oil rig. The oil is oxidation is loss. So with that, we can always remember the definition of oxidation reactions. In terms of oxidation state, that is oxidation number. When oxidation is carried out, it will lead to increase in oxidation number of an element. So the oxidation number of that element will increase, or you may say the oxidation state of that substance will increase Now, when we talk about definition of oxidation in terms of hydrogen, it's simply the removal of hydrogen. And in terms of oxygen, it's simply the addition of oxygen. So when oxygen is added to a substance, it is oxidation. When hydrogen is removed from a substance, it is oxidation. Reduction now. Just like we have seen in the case of oxidation, opposite is the case for reduction. So reduction will be gain of electrons. Reduction will be decrease in oxidation state or oxidation number. Reduction is addition of hydrogen, and reduction is removal of oxygen. So this is simply how to define oxidation reduction reactions. These 4 ways of defining oxidation reduction reactions. Still talking about redox reaction, we need to understand what oxidizing and reducing agents are. So oxidizing and reducing agents are also defined in the following ways. In terms of gain and loss of electron, the substance that is being oxidized is called reducing agent. That is to say, if you are oxidized, you must be a reducing agent. And if you are being reduced, then you must be an oxidizing agent. That is actually how these terms are defined. So we shall take a look at certain expressions to understand what we really mean when we say this is a reducing agent and this is an oxidizing agent. Looking at the equation copper sulfate plus zinc. Copper sulfate plus zinc to give us the compound zinc sulfate plus copper. So we are trying to look at who has been reduced and who has been oxidized, and who is therefore the oxidizing agent and who is the reducing agent. Now let's express that correctly on the white screen. We're just simply going to move this up. We have copper sulfate going into reaction with zinc metal, and that gives us zinc sulfate plus copper metal. That is to say, in stoichiometry, zinc has displaced copper. This is an example of a displacement reaction. Now looking at the reaction, we can say that copper was initially copper sulfate. In short, it is called copper 2 tetraoxosulfate 6, copper 2. So which it simply means that the oxidation number of copper here is +2. So coming into reaction with zinc, zinc reduced copper to ordinary copper. So you can see copper is no longer copper 2 sulfate, but it has now become ordinary copper. So what it simply means is that copper has been reduced from being in a company to being out of the company. Copper has been reduced by who? By zinc. And looking at zinc, zinc from here has been oxidized. So zinc has become zinc sulfate. So we can see that zinc has now become zinc sulfate. Zinc was initially alone, but now has merged with sulfate ion to become zinc sulfate. So what it simply means is that zinc has been oxidized, but copper has been reduced. Copper has been reduced from copper sulfate to ordinary copper metal. But zinc has now become zinc has gone from ordinary zinc metal to zinc sulfate. Can you see that? So this is actually what has happened. So what it simply tells us is that the reaction of zinc going to zinc sulfate is oxidation. Oxidation. This process is oxidation. And the reaction of copper sulfate, now copper becoming ordinary copper, is reduction. From copper sulfate to ordinary copper, reduction has taken place because it tells us that copper has been reduced to ordinary copper. So what it simply means is that the species that brings about oxidation and the species that brings about reduction have their own names too. So as reduction is taking place, oxidation is also taking place. So what it simply means is that zinc has led to the reduction of copper sulfate to ordinary copper. Why? Or you can also say that copper sulfate has brought about the oxidation of zinc from ordinary zinc metal to zinc sulfate. So in other words, we can say that zinc is the reducing agent. Zinc is the reducing agent. Or let's use another pen for that so that we can get to understand that better. So let's say, let me use a red ink. So in this case, zinc is the reducing agent because zinc has brought about the reduction of copper sulfate to ordinary copper. So zinc must be the reducing agent, and at the same time zinc has been oxidized. So copper on the other hand has led to the copper sulfate on the other hand has led to the oxidation of zinc from the zinc ordinary metal zinc to zinc sulfate. So what it simply means is that this compound must be the oxidizing agent. Oxidizing agent. So you can see that it is the oxidizing agent. So copper sulfate is the oxidizing agent, while zinc metal is the reducing agent. So the oxidizing agent has undergone reduction. It has been reduced to ordinary copper. The reducing agent has been oxidized to zinc sulfate. So we can see that that is actually why, that's what we talk about when we make reference to oxidation reduction reaction. So it is two reactions in one. They are taking place simultaneously. So while the reducing agent is being oxidized, the oxidizing agent is being reduced. That is actually what we have there. So we can see here, let's go to the definition once again. The substance being oxidized is called reducing agent. So we can see that the substance being oxidized is called reducing agent. So zinc has been oxidized. Look at it, oxidation, oxidation. Zinc has been oxidized and it is called the reducing agent. The substance being reduced is called oxidizing agent. Look at it there. Copper sulfate has been reduced to ordinary copper, and for that reason it is called oxidizing agent. Let's proceed. So looking at the equation, we can see that zinc has gone from zinc metal, which is ordinary zinc, to zinc ion, which is in the form of zinc sulfate. But copper has gone from the copper ion to ordinary copper, which is thus metallic copper, and that is reduction. So copper, that solution now becomes the oxidizing agent, while zinc is the reducing agent, as we have said before. So that is that. So simply we say that as oxidation is taking place in reactions, reduction is also taking place simultaneously. So if that is understood, as I believe, let's proceed to our next subtopic. That will be oxidation states and the balancing of redox reaction.